good evening, and welcome. Tonight, we're going to be taking a peek into what the night sky looks like in February. Sounds like an airplane's just now flying overhead. Apologize for that. But this is a monthly series I'm doing for 2021. We're going to look at what the sky looks like in February in the Northern Hemisphere and Southern Hemisphere. We're going to take an in-depth look at one of the prominent constellations of the month, and then we're going to learn a little bit more about space. So to start off, let's read about our Northern Hemisphere stars. The ecliptic, the path the moon and planets follow, gets as high in the sky as it can this month. When the moon is full in the late evening, you will notice how high up and bright it is. The ecliptic runs through Gemini, which is also high in the sky. Its two brightest stars are Castor and Pollux. One of the most famous stars in the northern sky is Polaris. It marks the tip of the tail of the little bear, Ursa Minor. Also, the binding of this book is really delicious. So, let's learn about Gemini, which is located, located right here up in the sky. Gemini. Here we go. I love the sound of this binding. Okay. Castor and Pollux are thought of as the heavenly twins. In Greek mythology, they were reunited in heaven after death. The stars, however, are not identical. Pollux is brighter and more yellow, and at 25 light years from Earth, it is half the distance of Castor. The bright stars mark the heads of the twins, while the two long ragged lines of stars mark their bodies. We have Ursa Minor, which, let's see, Ursa Minor that's Ursa Major. Ursa Canis Minor. Isn't it? Here it is, because there's Polaris. Ursa Minor. There we go. The star pattern of this constellation is similar to Ursa Major, but smaller and fainter. The second and third brightest stars, Kochab and Purkad, are known as the guardians of the pole. They never set, but appear to circle Polaris. Did you know Gemini contains an extremely unusual pulsar named Geminga? The sound of this book. Which gives out powerful pulses of gamma rays and X-rays, but not radio waves like other pulsars. If you could see gamma rays, it would be one of the brightest things in the sky. Interesting. Squeaky book. The North Pole of the sky is slowly moving in a circle because of precession, which is like the wobble of the Earth. It's kind of hard to describe. It will be nearest to the star Polaris in the year 2102. 5,000 years ago, there was no bright star near the North Celestial Pole. Alright, let's see what's going on in the Southern Hemisphere. Carefully turn the book to the other side. There we go. The Southern Hemisphere stars. There we go. How's that? Is it crooked? There. Still kind of crooked. Oh well. I'm gonna have to deal with that. There we go. February Southern Hemisphere stars. Looks fine. So this is a map of the constellations of the Southern Hemisphere this month. Let's read about it. It says, this is the binding. Anyway, although the Milky Way runs overhead at this time of year, it is hard to see unless the skies are really dark, because this is its faintest region. Instead of looking toward the center of our galaxy, we are looking out toward the edge. However, the two brightest stars, Sirius and Canopus, are virtually overhead on summer nights, with Puppis and Columba lying between them. Take a line from Sirius through Canopus, and you find the large Magellanic Cloud in Dorado. Now I'm a northern hemisphere person. I've never even been to the southern hemisphere, so if I mispronounce a name, like if that's canopus instead of canopus, or if this is not pupus, if it's like pupis or something, I don't know. Let me know in the comments so that I can learn and that anyone else who doesn't know can learn as well. So please let me know. But let's read about pupus, I assume. Which, let's find it on the map. Oh, I found it right away. Pupus. This constellation represents the stern of the mythical ship Argo, in which Jason and the Argonauts sailed in search of the Golden Fleece, part of a much bigger constellation until it was divided in the 18th century. Pupus only contains a number of moderately bright stars. However, it lies in a rich part of the Milky Way and contains many star clusters. Those look very pretty. You can see the Milky Way behind it there. And here's Dorado, which, let's find it on the map. Dorado is, I believe it's like in this section, right? Dorado. Right here. There we go. One of 7 celestial fish. This constellation represents a tropical goldfish, but it has also been referred to as a swordfish. It is best known for containing the large Magellanic Cloud, named after the Portuguese explorer Ferdinand Magellan, who first spotted the Magellanic Clouds in 1519. Then we have Columba. Let's find that now. Columba, right there. Columba. Look at all those little stars. Let's read about them. Carefully put the book back down. It's so squeaky. Columba, the dove, is the only constellation astronomers use today that gets its name from a story in the Bible. It was recognized in 1592 by a Dutch map maker called Petrus Plancius. He pictured the dove sent out by Noah from his ark. Alright, very interesting. You learn something new every day, especially on this channel. At least I hope so. Okay, carefully moving the book. Let's learn about one of the important constellations this month, which today is Canis Major. Now on this side, we see in a close look, normally there's a plastic page here that goes over this, so you can see what the constellation looks like. But this was a used book I got at the used bookstore, and whoever owned this book before loved it so much that they ripped it out, so it's not here anymore. But, I mean, I think we've all seen this constellation. It's just below Orion, and it has the brightest star in the night sky, and it's Sirius. So I think we're all familiar with what it's supposed to look like. It's a big old dog. Let's read more about Ursa Major, or Canis Major, not Ursa Major. That'll be another day. Canis Major. There we go. It says, oh, see, there's a dog. This is the greater of the 2 dogs belonging to the hunter Orion, the other being Canis Minor. Some Greek myths refer to Canis Major as Laelaps, the fastest dog of all, which was owned by Diana, goddess of hunting. Oh, Diana's a Roman god, so not a Greek myth. Anyway, that would be Athena. No, I lied. That would be Artemis. Although it is south of the celestial equator, Canis Major is visible from both hemispheres. It contains the brightest star in the sky called Sirius, known as the Dog Star. To the ancient Egyptians, however, it was known as the Nile Star because when it rose in the eastern sky just before sunrise, it signaled the annual flooding of the Nile River. In July and August, Sirius is near the sun, and in ancient times this was thought to contribute to the heat of the northern summer, so these times were called the dog days. Sirius A and Sirius B. See them there. Sirius has a companion star known as Sirius B, the first white dwarf star to be identified. It orbits Sirius every 50 years. White dwarf stars have reached the end of their lifetimes and are much fainter than normal stars. Sirius B has collapsed down to about 5 times the size of Earth. Although much fainter than Sirius, in the X-ray view here, Sirius B actually appears the brighter of the two stars. Oh, so that's actually Sirius B, I guess. Interesting. Star cluster M41. To the south of Sirius is this pretty star cluster, which was known to the ancient Greeks as a mysterious cloudy spot. Most of the stars, most of the stars are blue, but there are some red stars as well. The cluster is about 2,350 light years away and contains about 80 stars. And their star cluster, NGC 2362. Take a look at the star Tau through a small telescope and you will discover this little cluster surrounding it. Tau itself is a brilliant blue supergiant star, but the others are much fainter. At about 1 million years old, this is one of the youngest star clusters known. Let's see which star is Tau. Canis Major. The Tau star, let me bring this up a little, is, do you see it? Zeta, Epsilon, Sigma, Delta, Tau. So it's this star right here. There we go, this star. Alright, let's read about an astronomer. Let me carefully move this crinkly book so you can see more. There we go. Friedrich Bessel. Born into a large family in Germany, Friedrich Bessel, born 1784, died in 1846, worked from the age of 15 in an import-export firm. During his apprenticeship, he became fascinated with astronomy and math. At only 20, he amazed the experts by his calculations of the orbit of Halley's Comet. Eventually, he was put in charge of a new German observatory and went on to measure star positions with great accuracy. Now let me carefully move this up so you can see the bottom picture here. The motion of Sirius. Friedrich Bessel observed the movement of Sirius over a period of 10 years. His measurements showed that instead of moving steadily across the sky, Sirius traveled in a wavy line. He suggested that this was due to the gravitational pull of a companion star. Astronomers searched in vain for the star, but it was not until 1862 that the faint companion was spotted by American Alvin Clark while testing his new telescope. There's the companion star. So it says Sirius A is much brighter than its companion, that you need a large telescope to see Sirius B. So Sirius A moves like this, and Sirius B moves like only see it sometimes. Well, I mean, it doesn't move, we're the ones moving, but anyway, you know what I mean. Let's learn more about outer space. This month we're going to talk about star types. This up. Star types. There we go. If you look carefully at the night sky, you will see that the stars are not all the same. They range in size, color, and brightness. To learn more about the different types of stars, astronomers have examined starlight. They have found that a star's true brightness for most of its life before it begins to die is linked directly to its color and temperature. Starlight also tells astronomers about a star's mass, or how much material it contains, its diameter, or its size, and composition. Stars shine steadily most of their lives, but become variable in old age. Okay, sounds like my cat snoring. Stars that try to form with too little gas only shine dimly for a short time. Let's learn more about that. See the color of heat. Anything that is very hot will glow. Whether it is a star, an iron bar, or anything else, its color depends mainly on its temperature, not what it is made of. If an iron bar is heated in a furnace, first it glows dull red, then orange, then yellow. As the temperature increases, the iron bar becomes white hot, then takes on a bluish tinge. Let's learn about a star's spectrum. When light passes through a prism, it is split into a rainbow of colors known as a spectrum. In astronomy, an instrument called a spectrograph splits starlight into a spectrum. By looking at the positions and strengths of the dark lines that cross a star's spectrum, astronomers can find out the star's properties. Dark lines in a spectrum reveal a star's chemical makeup. Isn't that neat? Let's learn about the star colors. In the same way that an iron bar's color tells you how hot it is, a star's color is an indication of temperature. Stars are grouped into 7 spectral types, ranging from blue, the hottest, to red, the coolest. The letters O, B, A, F, G, and K, and M are taken from a much earlier labeling system before astronomers learned how to determine a star's temperature from its spectrum. So, type O, the hottest, is bluish white. Type B is also bluish white. Type A is white. Type F is creamy white. Type G is yellow. Type K is orange. And type M is red. Type O can be from 50,000 to 90,000 degrees Fahrenheit, or 28,000 to 50,000 degrees Celsius. And the coldest one, the type M, can be from 3,100 to 5,800 degrees Fahrenheit, or 1,700 to 3,200 degrees Celsius. Let's see. Typical cluster, in this case fictitious, contains a variety of stars. As all of them are nearly the same distance away, we know that the faint ones really give out less light than the brighter ones. Interesting. Color and brightness. Let me carefully move the squeaky book up so you can see. Color and brightness. Squeaky book. After measuring the color, which shows temperature and brightness of a group of stars, you can see here on this little graph, we can plot them on a graph. When plotted, most stars lie on a diagonal line, which is known as the main sequence. This diagonal stretches from the hottest, brightest stars at the top left of the graph to the dimmest, coolest stars at the bottom right. When stars reach the end of their lives, they leave the main sequence and swell to become giant stars at the top of the graph. These giants have cooled down and turned red, but their huge size makes them appear bright. When a giant star dies, it blows off its outer layer and the core shrinks and heats up. This tiny core becomes a hot, dim, white dwarf. So most stars lie on this diagonal line called the main sequence. Giant stars are cooling and dying, but their huge size makes them still appear bright. They're bright, but cold. And white dwarfs are dim, but hot. Very hot, but very small, so they appear dim to observers. Alright, let's learn about. Carefully move the squeaky book over. Here we go. There. And slide. There. That works for now. Squeaky book. Let's learn about main sequence stars. Stars spend most of their lives as main sequence stars. With little change in brightness and temperature, stars shine steadily by converting hydrogen into helium in their cores. Our sun has been on the main sequence for about 5 billion years and has about 5 billion more years to go before it swells to become a giant star. The time a star spends on the main sequence depends on its mass. The more massive stars last for the shortest time because they use up their nuclear fuel quickly. Interesting. Let's learn about the sizes of stars. Let me see. Yeah, perfect. Stars great and small. Astronomers usually compare the mass and diameter of stars with that of the Sun, a G-type star. Cool, yellow. This one. Which is of average size in star terms. Typical main sequence stars range from O-type stars with masses 15 times that of the Sun and 7 times its diameter, right down to faint M-type red dwarfs with masses and diameters only a fifth of the Sun's. Red giants are about the same mass as the Sun, but can swell to 50 or more times the Sun's diameter. White dwarfs have about the same mass as the Sun, squashed into a ball about the size of Earth. So let's look at these really neat diagrams. So we have a white dwarf. It's about the same diameter as Earth. The Sun is 865,000 miles in diameter. There's an O-type star, the hottest type, because it's white. It may be 7 times the size of the Sun. A red giant, which is the coldest, but it's swelling up because it's dying. It swells to 30 to 50 times the Sun's diameter. And then we have the red supergiant, which is so big it can't fit against this measuring diagram. It may be 300 to 600 times the Sun's diameter. So big that our brains can't wrap around something that size. It's huge. Let's learn about brown dwarfs. If a star tries to form with less than about 8% of the Sun's mass, its center never gets hot enough for it to become a real star. Instead, it glows faintly for a while. Low-mass failed stars are called brown dwarfs. They are most easily detected soon after they have formed by the infrared radiation they emit. The smallest brown dwarfs are roughly the size of the planet Jupiter. Some of the faintest dots in the infrared image of the Orion Nebula on the far right are thought to be brown dwarfs. So this is what the Orion Nebula looks like in visible light, but in infrared shows the brown dwarfs, the little dots, which you can't see in this one. Isn't that interesting? And then let me carefully move this up so we can read about another type of star. There we go. There we go, squeaky book. Variable stars, which this is apparently Mira, a red giant star. And when this book came out, didn't have a good photograph of it, but I guess that might be the best we can do for a star so far away. Let's learn about what a variable star is. As stars age and swell up, they often become so unstable that they alternately expand and contract. As they do so, their brightness varies. Some change at regular intervals of a few days or weeks. Others vary less regularly over many months. Stars of this kind are called pulsating variables. Some aging stars suddenly dim from time to time when clouds of dust form in their cool outer layers. So Mira is a red giant star that varies between 2nd and 10th magnitude over about 322 days. And here we're going to learn about another scientist named Subramanian Chandrasekhar. Indian-born physicist Subramanian Chandrasekhar, born in 1910, deceased in 1995, won the 1983 Nobel Prize for Physics for his work on dying stars. He calculated that no white dwarf could exist with more than 140% of Sun's mass. This mass is called the Chandrasekhar limit. A collapsed star core any heavier would keep collapsing and become a neutron star or a black hole. Alright, so that's the end of that. Let me love the sound of this book. It's so crinkly in the best way. Like not crinkly, but like creaky. You know what I mean? So that's the end of that. I hope you learned something tonight about our night sky, the stars. Take some time to look outside this month, this coming month, because this can be posted on January 31st, so you'll have all month to look up and try to see some of the constellations in your hemisphere that was highlighted. Let me know if you see any in the comments. Thank you so much for watching, and have a very good night.